Hi, I am B. Janardhan Reddy. In this video, I will show you an activity for parallel connection of bulbs or resistors. That means when the bulbs or resistors are connected in parallel, the current drawn from the battery is equal to the sum of the individual currents drawn by the bulbs. That is I is equal to I1 plus I2 plus I3. That is the sum of currents, say I1, I2, I3, etc. in the separate branches of the parallel circuit is equal to the total current I drawn from the source. That is I is equal to I1 plus I2 plus I3. Here I is the total current drawn from the source and I1, I2, I3 are the individual currents flowing through the branches. Okay, so I is equal to I1 plus I2 plus I3. The total current of the circuit is equal to the sum of the individual currents in separate branches that will be shown in this activity. Okay. Aim of the activity to show that the sum of the individual currents drawn by the bulbs or resistors is equal to current drawn from the battery. Material required in order to this activity are different bulbs, multimeter, ammeters, battery, switch and connecting wires. Here you can see the material required. These are the bulbs of different resistances. That means the filament in each bulb has different resistance. Okay. And this is a multimeter which is used to measure resistances, current, voltage, etc. And this is an ammeter. It is a milliammeter. It measures current in milliamperes. And these are the two 9-volt batteries or dry cells. Okay. I will connect these two dry cells in series so that it will become as a 18-volt battery. And this is a switch and these are the connecting wires. So this is the material required in order to do this activity. Okay. And here is the procedure. Step 1. Measure the resistances of the bulbs with a multimeter and let their values as R1, R2 and R3. So here are the three bulbs, bulb 1, bulb 2, bulb 3, and let us measure the resistance of each bulb by using the multimeter here. So this is a multimeter by which I am going to measure the resistance of each bulb. So I placed the multimeter knob at 2000 ohms. That means the multimeter is ready to measure the resistance up to 2000 ohms now. So I am measuring the resistance of the first bulb. It is 100 ohms. Okay. So R1 equal to 100 ohms. The same way I am measuring the resistance of the second bulb. It is 150 ohms. R2 equal to 150 ohms. Next, let us measure the resistance of the third bulb R3. It is 200 ohms. So these are the resistances of the filaments in the bulbs. Okay. So R3 equal to 200 ohms. So the resistance of each bulb is different. That means they draw the different currents when they are given the same potential difference. You can see that later. Turn the multimeter off. Now, step 2. First, we have to connect a circuit as shown below. See here, I am connecting a circuit here. So this is a battery, two 9 volts dry cells have been connected in series. That is the potential difference between the two terminals of the battery is 18 volts. So this is the negative terminal and this one is the positive terminal. Between these two ends, the potential difference is 18 volts. This is a switch and this is a milliammeter which measures the current in milliamperes. Okay. So I am connecting ammeter in series like this. And these two are the 2 points P and Q. Between these 2 points I am going to connect the 3 bulbs in parallel. So see here how I am connecting. Like this. So the bulbs have been connected in parallel between P and Q. And in order to measure the current in each branch, I have connected a milliammeter in series. Okay, so ammeter should always be connected in series in order to measure the current in the circuit. Now, step 3. Switch on the circuit and measure the potential difference across each bulb using a voltmeter or a multimeter. See here. Now I am going to switch on the circuit. See here. When the switch is on, the bulbs are glowing. And here ammeters also showing some current. So in each branch some current is flowing. So before measuring the currents in each branch, let us measure the potential difference between the two ends of each bulb. By using the multimeter, I am going to measure the potential difference applied between the two terminals of the bulbs. See here. First I am measuring that means how much potential difference is applied between the two terminals of the bulb, that I am going to measure now. So I am placing this multimeter knob at 200 volts DC so that it can measure up to 200 volts. So it is 18 volts. That means the potential difference applied between the two terminals of this bulb is 18 volts. Similarly, let us measure the potential difference applied between the terminals of this bulb. See here, same 18 volts has been applied. Same potential difference is there between the ends of this bulb and the ends of this bulb. Next, I am going to measure the potential difference applied between the two terminals of this bulb. Same 18 volts. So the potential difference applied between the two ends of each bulb is 18 volts only. That is, the battery voltage itself has been applied. That means the potential difference between P and Q is 18 volts. So even though the same potential difference is applied between the two terminals of each bulb, the currents flowing through them are different. So let us see here. So let us reconnect the circuit and see here. This is a battery. That means two 9 volts dry cells have been connected in series, and it gives the potential difference of 18 volts. Okay, and this is a milliammeter which measures the current in milliamperes. And here are the 2 points between which I am going to connect the 3 bulbs in parallel. So when the devices, say resistors, bulbs, are connected in parallel, the same potential difference is applied across each of them. Okay, see here. Here is a bulb. I am connecting this bulb through a milliammeter in order to measure the current flowing through it. Second bulb, see here. So here are the 3 bulbs I have connected in parallel between P and Q. And just now we have seen that the potential difference across the two terminals of each bulb is 18 volts only. That means here the same potential difference of 18 volts has been applied across the two ends of each bulb. Okay. Then turn the switch on. So when the circuit is on, current is flowing through the circuit. For that reason, bulbs are glowing. And here you can see milliammeters are also showing readings, isn't it? So how much current is flowing through this branch, and through this branch, we can see here. Okay. Step 4. Measure the electric currents flowing through each bulb using ammeters. Let I1, I2, I3 be the currents flowing through R1, R2 and R3 respectively, and let I be the current drawn from the battery. You see here. So these are the currents. So here I is the total current drawn by the circuit from the source, that is from the battery, and this current is split into 3 different parts. Okay, so I1 current is flowing through the resistor R1. I2 current is flowing through the resistor R2, say that is bulb, and I3 current is flowing through this. Okay, so these are the currents flowing through each bulb. So here I equal to 390 milliampere, that is the total current of the circuit. I1, I2, I3 are the currents flowing through the bulbs. Here you can see the readings of the milliammeters. Okay, it is 390, here it is 180, here it is 120, here it is 90. Okay, so sum of the currents through the bulbs I1 plus I2 plus I3 is equal to 180 plus 120 plus 90. Just now we have noted the readings as I1 as 180, I2 as 120 and I3 as 90. So if you sum up these values, we get 390 milliamperes. This is nothing but the total current drawn from the battery. This is equal to the current drawn from the battery I equal to 390 milliamperes. That means I is equal to I1 plus I2 plus I3. I is the total current drawn from the battery, and I1, I2 and I3 are the individual currents drawn by the bulbs. Okay? So when the bulbs are connected, that means when the resistors are connected, the sum of the individual currents in each branch is equal to the total current drawn from the battery. So here is the result of this activity. The current drawn from the battery is equal to the sum of individual currents drawn by the bulbs. Okay? Thank you.